Rachel, and for the past couple of weeks, I've been working to create this big database of information centralizing all maize research. So this has involved reading over 302 research papers and counting, talking with scientists, laboratories, and researchers, understanding super complex scientific topics, and then actually writing and publishing this paper. And no, I'm not a PhD student, I'm not a master's student, I'm not even an undergrad student. I'm just a high school student who is obnoxiously passionate about agriculture and the inefficiencies in our global food production system. In the past, my passion and curiosity has led me down so many different rabbit holes, from quantum computing to CRISPR and agriculture, where I proposed an idea for a transgenic strand of maize, basically combining a whole bunch of different edits to make one super crop. And now a deep dive into extreme poverty and the connection of agriculture in this network and all of the intricacies and complexities that come with it. So while none of these deep dives involved writing a scientific paper, they each taught me how to go super deep into topics, like 2 years deep. I learned how to think about complex systems and map different stakeholders and root causes. And above all, I've learned that passion and curiosity are two major superpowers to help young people accomplish super cool things and get opportunities that they're not technically qualified to have on paper. So I've learned a lot writing this paper over these past 2 months, which I wanted to share with all of you today. And I hope that this will help you to dip your toe into reading or writing a scientific paper and maybe even conducting a big literature review of your own. Number 1, map breadth and depth. So in a good comprehensive scientific paper, there is both a wide breadth as well as a deep depth, which is different to how many people think. Many people are programmed to either give this big overview with a big introduction into the problem and very surface level, or something with a lot of technical jargon in a super niche area, which is very deep. In a scientific paper, you need both this wide breadth, like an introduction, breaking down the problem in a root cause analysis, as well as a deep depth in a specific niche area. To find what you need to go in depth on versus just giving breadth, I recommend plotting all of your topics on a graph that I designed. So first, create an extensive list of all of the topics that you're going to cover in your paper. So mine looked like this. Then plot each topic in the best fit quadrant. So quadrant 1 is overview and context. Quadrant 2 is niche expertise, so areas demanding a deep expertise and specialization in order to actually understand it. Quadrant 3 is a comprehensive synthesis, so topics where a blend of breadth and depth is necessary for understanding. And quadrant number 4 is strategic and focused insights, so topics that benefit from a concentrated and specialized focus. Number 2, prove your thesis. So we often only think that there's a thesis in an English paper, but connecting back to a thesis in a scientific literature review naturally creates this connection back to impact, to the question of why does this matter? Because at the end of the day, the purpose of any scientific body of literature is to make an impact, to advance an industry, to articulate important information, or to save someone time. So this is the level of impact that you need to be consistently showing and proving in a way throughout your entire paper. Even if your paper is technical, the purpose is to make an impact. So show what that impact is. Number 3, use Zotero. So you can download the Zotero app and use it to keep all of your references straight. So you can set it to the reference style that you need. You can copy and paste in a link to your paper and it will cite it properly. And this alone has saved me tens and tens of hours. Number 4, create a super detailed outline. So having a detailed outline that hits on certain papers, that hits on sections and how you're going to structure each of these sections, specific information, stats, all of the really nitty-gritty things. While it seems like a lot of time in the moment to create a 10-15 page outline for a 30-page paper, it actually saves you so much time down the line, and it's my favorite way to keep everything organized and make sure that I don't leave anything important out. And number 5, get feedback early on. So I got feedback on the 1-paragraph summary that I made at the very beginning, then on the outline, then on each individual section. Now, it's great to get all this feedback, but it's what you do with the feedback that matters. Don't be afraid to change your original idea. You may have to cut entire paragraphs, but that's part of the process, so trust it. Remember that feedback and criticism isn't directed at you, so don't take it personally, because harsh criticism and feedback is actually your superpower to create this wide breadth which incorporates many different ideas and perspectives instead of your own limited ideas. Number 6, don't make it fancy. Writing a scientific paper is not poetry. The goal is not long, fancy sounding sentences that go on for 5 lines. The goal is to make it as comprehensive as possible, not to make you sound smart or fancy. And being able to explain things simply is actually harder than explaining things with all the scientific and technical jargon. And there's only one way to be able to do that, and that is to actually understand what you're talking about. And to do this, you have to read the papers. You have to understand all of the terminology. There's no shortcut that will help you or no AI tool that will get you there. And number 7, use Sci-Hub. So especially as a young person who isn't affiliated with any institution like a university, getting access to some papers or journals with all the paywalls is very hard. So for that, my recommendation is to use Sci-Hub. Again, this site has single-handedly saved me dozens and dozens of hours searching for the correct paper and has given me access to hundreds and hundreds of papers. So thank you, Sci-Hub. And number 8, keep everything. So when doing a big literature review, there can be a lot of wasted time and inefficiency. You can first spend a lot of time finding a paper, open it, find a set, go back, open it again to find a diagram, go back and open it again to find the right paper. And before you know it, you've looked at that same paper 5, 10, 20 times and wasted so many hours in the process. So for that, I have 2 suggestions. Number 1 is to do everything. So write all of your information while you have that paper open. But sometimes it's hard to make sure you're organized to do all that. So my second piece of advice is to write everything that you think that you'll need in a separate Notion or Google Doc. So include all screenshots to graphs or diagrams and keep a running list of all information so you can easily go back and just reference that doc instead of having to revisit and find that information in the original paper. And number 9, spend time on the abstract. So the abstract is the most important part of your entire paper. Somebody should be able to read your abstract and understand what the entire paper is about. If the abstract doesn't do this, then it's not doing its job. So before you write the abstract, make a list of the most important things that your reader needs to understand. For example, while yes, understanding the problem is important, a big root cause analysis is not needed in the abstract. Save that for the introduction and save all of the statistics also for the introduction. The abstract should be more on what you will talk about in the methods and the body of the paper. So all of the complicated science explained extremely comprehensively in only a few sentences. I would recommend writing the paper first, then going back to the abstract to make sure that it is as targeted as possible. And number 10, show don't tell. So once your manuscript is written, go through and flag all complicated topics or sections that you think are hard to understand. How can you replace that paragraph with a schematic, a diagram, or a graph? Because we as humans are visual learners and we learn better and we grasp concepts easier if we see them and don't just read about them. And lastly, understand the system. Don't just think that because you're writing a paper about the mechanism of CAR T-cell therapy in eukaryotic cells, that you don't need to also understand the history of CAR T-cell therapy, or how CAR T-cell therapy operates in other cells, or the negative effects of CAR T-cell therapy, because all of this is important for understanding the network and the system as a whole. It is easy to say that you're only going to focus on a very specific topic, but in doing this, you're ignoring all of the other important information that plays into this topic. And without this information, there is no context. So you're basically pulling something very micro out of context. So learning about the network surrounding that topic and writing about that network in a lot of depth is super beneficial, not necessarily for the written work that you'll be doing in the body of your paper, but for your own understanding so that you can then connect all of these complicated dots, make connections, and then write about that within your paper. And that is my 2 cents on how to write a scientific paper. But above all else, your ability to get super curious and super passionate about a topic will be far more impactful and worthwhile than any of these pieces of advice that I have given you. So if you can wake up every morning at 5 a.m. for months and months and months to read hard papers and seek hard knowledge, that inertia will define not only your final product, but the enjoyment that you have along the way. Because remember, we are so lucky to live in a time when knowledge is so accessible. And breaking down knowledge is really a privilege, not something to be rushed and checked off your to-do list. So best of luck with your literature review or your scientific reading or writing, and I hope all the best. I hope that this was helpful and you gained something from this video, and I will see you all next time. Bye.